Okay, today is about reflections. And if you take a graph that's one of your standard ones, would you please graph the absolute value of x? Just make a quick sketch of it. It's a super simple shape. Hopefully you did that. Raise your hand if you knew that that was the absolute value of x. Okay, good. Now, what if I did this to it? Y equals absolute value of x minus 2 plus 3. I just changed it a little bit. Would you grab yours and move it? Hopefully it won't move your axis over, but if you grab it one little piece at a time, that's probably a good idea. What does that minus 2 mean? Does that mean 2 to the right or 2 to the left? 2 to the right. All right. And then what's that plus 3 mean? Up 3. Show me where it is. Good, 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 good. Okay, everybody's getting it right. It's over here. Like that. Okay, now what if I throw in a negative? Do you get how negative means opposite of? All right, and if I take all my y's and make them the opposite, if I put this right here, a negative right there, which then would translate to like a negative right there. Okay, the negative out in front. Have I been telling you the stuff on the outside is up, down, and the stuff on the inside is left, right? If I got that straight? Good. So the outside is an up-down thing. Along with that is an up-down thing. That's an up-down reflection. So how do I do that? This is tricky for a lot of people. Can you see I do not do that? It's a reflection over the x-axis. So this V gets reflected, and how high was it before? It was up 3. Now it's going to be down 3 and upside down. You get the difference there? The one I just did, that's a correct reflection. Can you guys do reflections with your little scissors tool? Okay. Can you flip things? You can rotate it. Okay, so you can rotate it, but you can't truly flip it. Okay. All right. So let me show you something. Y equals negative x plus 2 squared minus 5. Do you get that there are 3 things happening to my parabola? That tells me it's a parabola. This tells me one thing, this tells me another thing, and that tells me a third thing. Do you get that math has an order to it? You have to do things in the right order, otherwise you'll get different answers than each other. If he multiplies first and you add first, it's going to be different, right? So I need to tell you what order to do it in to get it right. So I like starting on the inside because all hard math problems, you start on the inside of the parentheses, right? Start on the inside, work your way out. Talked about that since the beginning of the year. So we're going to start in there. So first you make a little parabola. Everybody make yourself just a quick one like this. I don't mind that you don't have distinct points. Just get it close. And then we're going to do a bunch of stuff to it. The first thing you should do is on the inside. So number 1, number 2, and number 3. Number 1 is the inside there, and what does the plus 2 mean? Left 2. Everybody grab your parabola, move it left 2. It's really important you do it in the right order now. On the outside, we're done with on the inside now. On the outside, there's 2 choices. There's that minus 1 and there's that minus 5. This one means multiply by negative 1. Do you get that that's different than subtract 5? And I'm trying to give you a hint on which one comes first, multiply or subtract. Normal math, which one comes first? Multiply. So I should multiply. I should do this next, not the 5. So how do I do this? That is a reflect. Which way? Up, down. Which goes over which axis? Reflect over x. Because it's up, down. All right, and then the last thing we do is that 5. And that 5 is what? Up or down 5? Down. Okay, so far all I've done is move it 2 to the left. Now I've got to reflect it over the x-axis. So that would make it go like this. There, it's upside down now. And what's the last thing? Down 5. There we go. Started right here. That's the parent function, the red one. And I moved left 2. Then it got flipped upside down. And then it got moved down there. Okay? I'd like you to try one without me now. This is the square root one. Do you remember what the parent of that looks like? The ramp. Start by drawing the ramp. Then go to the inside. Get that done. Then move to the outside. Do those in the right order. And then show me where you think it is. I'm going to pause for a second while you try that. Okay, so your first job was to draw a little ramp shape, and it looks kind of like this. And then you had to move it three things actually. So show me where it ended up, and I'll tell you if you did it right or not. All right. There's a lot of different answers here, so I'm not going to tell each of you because it'll be too depressing for you. I'm going to show you what you should have done, and you tell me if yours ended up in the right spot. All right, this -1 that we start with, does that mean right one or left one? That means right one. How many of you started with that? Raise your hand if you did. Okay, good. Now, what does a up-down flip do? It does that. That's an up-down flip, not a left-right flip. And then the last thing is to take this from here and move it where? What's that +4 mean? Up 4. That's where it should be. Now, does the order matter? Yeah. If you do it in a different order, you will get a different answer, and sadly, it's a wrong answer. Now, I shouldn't be just the one who decides whether it's right or not. I can show you proof that it is here. And the proof I'm going to use is an XY chart, and it should be your best friend on a graphing test, because you can tell if you're right or not. I don't have to. Wouldn't it be nice if during the test you could walk up and say, Mr. Server, is this right? Of course. And if I said, no, it's not right, you'd notice you should fix it. Well, you can ask yourself that question by just making an XY chart and sticking in any number. Why would you pick something like 23? Pick a nice number like 1 or 0. Okay, I'm going to pick 1. I'm going to put in a 1 for the x. I put a 1 right there, and then let's do it from the inside out. So what's 1 minus 1? 0. Square root of 0 is 0. Opposite of 0 is still 0 plus 4 makes. Now I know 1 comma 4 has to be on my graph. Over 1 up 4. Look at that. It's on my graph. Now, if I had come out with like 1 comma negative 2, I'd known, wait a minute, my graph's supposed to be down there. I did it wrong. See what I mean? So you can know if you did it right. All you got to do is stick in a point. Now, is it possible you could have done it wrong and you'd get unlucky enough to have picked the 1 point that was right? Yeah, I suppose. But it's really unlikely. Okay, so it's a great way to check yourself. I'd like you all to put in a 5 and tell me what you get. Some people are awful at this, and I need to know who can do this and who can't. Stick a 5 into the function. 5 goes with what? Mr. V, tell me what to do. Square root is 5 comma 2. Raise your hand if you had that right. Okay, good. All right. So, wait a minute. 5 comma 2 over 5 up 2. Yeah, that seems like it's possible. You know, it's all just a matter of how high, what was my scale, you know, how high did I move it up? Seems believable. All right, so that is moving and flipping. And the flipping are technically called reflections. The last thing is, how do I make it reflect left-right? I was doing all up-down flips. y equals absolute value of x, and then how do I make an absolute value flip left or right? Negative on the inside, yes. Because remember, left right's in here. So if you want a left right flip, stick a negative there. But with the case of the absolute value, it's a V shape. Do you get if I make that flip left right, it's going to be right on top of itself? It's not going to actually change at all. Because this side will come over and it'll lay down right on top of where the other one was, and vice versa. So it doesn't actually change. Now think about that. Absolute values. Why shouldn't it matter if we stick a negative on the inside? Because you're doing the absolute value of it anyway, right? Again, it doesn't matter what it starts at, 5 or negative 5 or 5 or negative 5. It doesn't matter how if you switch it 10 times, it's still going to come out the same. That's why this graph doesn't look any different. Would that be also true of the x squared? Would you use that same logic to say, oh, here's x squared, and I'm going to flip it left, right. Do you get why it won't matter? Because there's a negative on the inside, and then when you square it, it doesn't change. I mean, it's still positive. Doesn't matter if I put in 2 or negative 2, you're going to get the same answer. That's why left-right flips on these kind of shapes are dumb. So if we're going to do a left-right shift, we pretty much always do a left-right shift on the ramp one. Because you can actually see when a left-right shift happens, that thing starts going this way instead. Okay? So that would be like this. Y equals the square root of x makes the ramp. And then if I want to make it flip, I put a negative in there. Now some people say, wait a minute, you can't do square roots of negatives. Exactly. That's why if we want to get something to show up for negative 2 on my graph, I got to make it negative of negative 2. See what I mean? Now I can put in a negative 2 into here, and it'll be okay because there's already a negative there. So negative plus the other negative on the negative 2 makes it like this, negative of negative 2. And that makes positive 2, and that actually has a square root. That's why I can make the graph go over here into negative territory by putting a negative on the inside. All right, I think I've covered pretty much everything you need to know. So the rest of the time is work time for you. Probably do one other little thing, but almost all the rest of the time is work time.